Hello everybody, thank you for joining me today. My name is Minam and today we're going to be looking at circular orbits. So some of our learning objectives are to understand what circular orbits actually are that natural and man-made satellites both follow, and to recall that radius and velocity are inversely proportional when we're looking at orbit. Okay, so I have for you here a top-down view of the Earth here and the moon orbiting it right there. Okay, so what we need to first understand is that the Earth exerts a force on the moon, gravitational force. So let's just say give that the symbol big G. And so the moon also exerts an equal and opposite force on the Earth. Because remember, this is a Newton's third law pair now, right? So Newton's third law tells us that for every action we have an equal and opposite reaction. So if the Earth exerts a gravitational force on the moon also exerts a gravitational force on the Earth. Okay, but we also know that the moon is traveling forwards, right? We know that it's rotating around the Earth. Okay, so there's also a force in that direction. Now, what links together force and movement, right? So F is equal to ma. So we know that the moon has mass, right? Okay, of course it has mass. It's stuff, right? It's the moon. So we know that the moon has mass, and we know that there's a force acting on it forwards, which is what causes it to orbit the actual Earth itself. So by extension, we also know that the moon is accelerating. So is accelerating. Okay, but is the moon actually speeding up? Well, no, right? Because we know that the moon rotates around the Earth every 28 days. So what is this? So it's really going at a constant rate, right? It's not speeding up or slowing down. So what is this acceleration actually doing? Well, if we have a look at the moon, say like a few hours later, right? So the moon is here now, and so it's still having the force of gravity exerted on it by the Earth here, and it's doing the same back to the Earth, right? And now the force is in this direction. So really there's been a change in direction. Now, what is velocity? Velocity is speed with direction. So to change that, and this is very important, and this is things that often students get confused with, to change the direction of an object, there must be acceleration. Okay, so that's why we say that the moon is accelerating around the Earth, because not so much that its speed is changing, its direction is changing, and to change direction we need a change in so we need acceleration. Okay, so that's why circular orbits also always have an acceleration. So now what we also want to know is that the radius between an object that it's an object that's orbiting another object and the velocity that that object is orbiting at are inversely proportional. Okay, so let's put that in symbols right here. So our orbit is, let's do that again. Okay, so our orbit is inversely proportional. Remember, that's shown by 1 over the velocity that the object orbits at. Why is that? Well, if you think about having a stick, right, with a string on it, if the string was very long and you were to spin it around, the ball at the end of the string, right, would go around the actual, and would actually orbit the stick at quite a slow speed. But say you were to make the string very short, you could just flick your wrist like this and it would go around extremely fast, right? That just makes sense intuitively. Well, this is because this is linked to by something called centripetal acceleration, right? So that's what the fancy physics word is for actually acceleration that only changes direction. Centripetal acceleration, right? This is something that I cover more at A level, but for now you really need to understand that the higher an object is away from another object. So say if the moon was twice this distance, it would orbit the Earth at half the speed. Okay, radius between an object orbiting and the actual object itself is inversely proportional to velocity. Okay, so now let's have a look at so we've been talking about this entire time about the moon, right, which is a natural satellite. Now let's have a look at a man-made satellite. Okay, you can see here that there is a white dashed line going to a specific point on Earth. That's because here we're looking at something called a geostationary satellite.